guys. Welcome back to another lesson that I have no markers. Hold on. Can't start it yet. Okay. We can now. I got markers. Hope you're doing well. It's Monday when I'm recording this. Man, does it feel like a Monday. It was a long day today. It really was. So, we talked about the very first lesson of geometry, points, lines, and planes. Now we're going to talk about some linear measures, specifically line segments. So just to get started, look at the picture. It's a pretty cool looking picture, right? Nice visual of a cubit, okay? So ancient Egyptians, when they were trying to measure things, they first started out with what's called a cubit. And a cubit started at, well, right here at the base of your forearm here, or where your elbow is, and all the way out to your fingertips was one cubit. So you could measure something just like this. And when you had 10 cubits, that became one rod. So they measured things based on their own body. Now, we don't do that as much today. I mean, some people still do. But we have rulers. We have other means to measure things with. Okay, so not just our body anymore. Okay, but I thought that'd be kind of a cool little thing to tell you about. Standards, that's okay. We don't need those right now. Vocabulary, we're going to talk about a line segment. And then we're going to talk about what congruent means. And what are congruent segments? Okay? So here we go. And once again, you can either download the PowerPoint slides or write on a separate notebook. Line segment. Okay, what is a line segment? Well, it's just what it is. It's a segment that's measured between two endpoints. Not a very good definition, but it pretty much describes what this picture is. We have endpoint A and B, and we have some sort of distance between them. That's a line segment. Now, how do we label it? Well, the two endpoints you pick with a bar over it. Okay? It's different than when we were naming a line, right? We had a line symbol above it. So there's a big difference there. In this case, we just have a bar. Okay, that's a line segment. Now, does order matter? In this case, no, it doesn't. I could have named this BA if I would like. Line segment BA. Okay? So, either way. But what we're going to do is we're going to take a line segment, we're going to chop it up and find different measurements, okay? And then we're going to talk about the line segment addition postulate with them. So let's do some application first, might as well. So find the length of AB using a ruler. So here's a ruler I have for you. Okay, so how long or what is the length of AB? Well, take a look. I'm thinking, here's 0. We're starting out here. So coming all the way across, that's 40, 41, I would say 42. Okay, so the length of AB is 42, and this is in what, millimeters? Okay, millimeters. Now you're probably noticing, which maybe you did, maybe you didn't, I didn't put the bar above it when I did that, okay? Typically, when you're not using the symbol, you're talking about measurement, okay? So I could say that, I can still say that this is line segment AB is 42 millimeters, okay? But I'll use this if I'm naming it. So you need the bar if you're naming. Without the bar, then you're talking about a distance. That's a good distinction, okay? Let's try another example. Centimeters this time. What's the length of this line segment? Okay. So looking at it, I'm going to say what? 4, that looks like a half. Okay, so 4.5 centimeters. So AB is 4.5 centimeters. Okay. Once again, I didn't put the symbol above it because I'm talking about a distance there. Okay? So, betweenness of points. And I'm modeling this off of a textbook. That's why it's kind of worded the way it is. This is also called the line segment addition postulate. Another name for it. Okay? So what this states is that I can look at the whole segment. let's look at everything that PQ has. So here's the whole segment PQ, and it's equal to the smaller segments added up. Okay, so it's equal to PM and MQ. If I add those two chunks together, I get the whole thing, right? Okay, and that's what this segment addition postulate is talking about. So if you want your notes, just to emphasize a little bit further, okay? So this was the whole segment. These are the parts that make up the whole segment. And that segment for us is what, PQ. There it is, I'm sorry. Okay, so that's what we're talking about in this slide. Okay, so we're going to practice writing these. Okay, remember, mathematics is like a language. We need to know how to read, write, and interpret it. This is just one of those cases. So the whole segment, PQ, is equal to all those smaller ones added up. Now, if there was another section to this, I would just plus whatever it is. I could just keep going. This marker is dying. We're switching to green. All right. Okay. So let's try this example here. Find BD. Now notice, they didn't put the symbol above it, so they're talking about finding a distance. Okay, finding the whole length of a line segment here. Okay. So, and actually, I don't think I need. I think I'm good. Usually, I keep my teacher notes handy in case there's something else I added to this that I needed to tell you. Okay, so let's go ahead and let's do some calculation here. So BD. BD. Notice how BD is the entire line segment, right? Now, what makes up that line segment? Well, this guy, right? BC does, and CD. Let's write that down. So BC plus CD. You could switch the points if you want, no big deal. So BD, I don't know. What's the length of BC? If you look at the slide, it's 16.8. What's the length of CD? 50.4. Okay. Add those two distances together. And what do we get for that guy? I think it's going to be, what, 62.7? 50 in that makes what, 66? 0.8.4 gives you what, an extra 1.2? 67.2 millimeters. That's the total length. If they give you a unit, like inches or feet, please make sure you do that. Always put it there. And we're done. Okay, that's the total length. You're probably asking, as much as a lot of students in geometry, do I have to write this? I could have added this and got to the answer quicker. I know you could. The reason why I'm saying write this is because you're getting used to using the labels and the symbols and setting this up, okay? It's making sure you can read mathematics. That's all it is, okay? So it's a little bit of a pain right now, but just get used to writing it this way, okay? Any questions? Good, very good. I'm glad there's no questions. Okay, next problem. Find the measurement of LM. You can always pause the video and figure it out yourself. It's not a problem. I'm going to write out the full equation, okay? So, what I'm going to put here is the whole line segment, which is what, LN. See how LN represents everything? What parts make up that line segment? So here it is, LN, LM, and MN. They are the two that make it up. Okay, so LM plus MN. Okay, those two parts of the whole thing make up LN. Okay? Plug some values in. Now, LN I do know, that's 4 centimeters. LM I don't know. That's what I want to figure out. MN is 2.6. So this is just a subtraction problem. Subtract 2.6 from both sides. So we get 1.4 centimeters for our final answer for that after we subtract. Once again, yeah, I know. Could you subtract those and get your answer faster? Absolutely, and that's fine. Okay, you're going to be able to do that, when you're practicing this. But just for your notes, try and write the equation out. Okay, just get used to writing the symbols. That's all I'm asking. Okay. Okay, last one, and then I believe we're going to shift just a little bit, something a little bit more involved. Okay? Find the measurement of TU, and I would encourage you, pause the video, pause the video. It's been a long day, guys, it really has. So, TV is equal to TU plus UV. Okay, the whole thing equals the parts that add up to it. I know what TV is. That's 3 inches. I don't know what TU is, but I know what UV is. It's what, 1 3/8 of an inch. Okay. Now we're going to subtract 1 3/8 off both sides. Okay. So 3 minus the 1/8. What's that going to be? 1 5/8, I believe, right? 1 5/8 of an inch. Is it inches? Yeah, inches. Okay. What takes 5 more to make this guy a 2, and then add 1 more gives you a 3. So 1 5/8. Okay, not a bad subtraction there. Any questions? Hopefully not. Okay. Could you just subtract those ahead of time? Yes. Okay, let's change this up. Let's throw a little bit more algebra involved. And what is the strategy for solving this guy? Well, let me tell you, it's not that hard. Anytime I see a problem like this, the first thing that pops in my mind is picture. Draw a picture. They don't give you one, and they don't. They say find the value of x and st if t is between s and u. So t is between s and u. That's what I would draw first. Now, does it matter where t is located? No, as long as it's in between. This is a rough sketch. I'm going to put that down. Rough sketch. It's not drawn to scale whatsoever. We could be plugging numbers in, you're like, wait a minute, this is smaller than this guy. It shouldn't be drawn that way. That's okay. Just having a picture helps, okay? They give me some measurements here. From S to T, it's 7x. I'm going to write it on the picture itself. From S to U, okay, and let me just erase that. The whole distance is 45. From T to U, it's 5x minus 3. I just read the problem, and I drew a picture with the proper label. Now, are you going to do this in the real world if you're working construction or anything like that? No, you're not. This is just seeing if you can, stay in tune with your algebra skills. Can you read and interpret the problem? Can you draw a picture and come up with an equation, thinking a little bit critically? Okay. More than likely, what you're going to be dealing with out there in the real world is what you see here. Okay. But this type of problem is just kind of expanding your algebra mind a little bit. That's all. Okay. I think a lot of people always complain about that. It's like, no, there's application, but sometimes we just want to see what you can do. All right. So the whole thing is SU, and that's ST plus TU. That's what makes it up, right? SU is 45, ST is 7x, TU is 5x minus 3. Okay. Now we just solve for x. So 45 equals 12x minus 3. Add 3 to the other side. Divide. We get 4 for that guy. Always ask yourself, are we done? No, we're not done. We got to find ST, right? See how this says it? Find the value of x and ST. We got one more thing to do. Okay, so ST, how big is this guy? Well, we know what X is, so now we just plug it in. Okay, so 7 times the 4. So the length of that's 28. Okay. Now, we should check to see if this works out, right? If this is 28, the whole thing's 45, I can figure out what this is by a little subtraction, right? Now tell me the length of this. And then I can confirm it by plugging 4 in. Okay? So, oh, why not? Well, let's give it a shot. Okay? Let's plug 4 into here for a second. So TU would be 5 times 4 minus 3. So TU is 17. Is 28 and 17, sorry. If I add those up, do I get 45? I do. So for these problems, you can always check your work. If you know what the whole length of a segment is, see if the parts add up to it. And they should. Okay? All right. I believe this is the last one. Oh, yeah. And then we're going to talk about congruent. So let's do one more. And I'm going to draw a picture. I highly encourage you to do this one on your own. Okay, draw a picture. See what you come up with. It says W is between X and Y. So we'll say X is here, Y is here, W, oh, I don't know. I'll put W there. Rough sketch, okay? When I find the measurements, that sketch might not be accurate, but this at least allows me to plug stuff on it. WX, right here. Now, notice, you see how it's backwards? I have XW, they said WX. We already talked about at the beginning of the lesson. You can flip the points, it's okay. There is a situation you don't, that's rays, and we'll talk about that when we talk about angles. But for line segments, it doesn't. So don't be afraid if that happens. So 6n minus 10, xy, the whole length, is 17, and then wy is 3n. Okay? All right, I'm going to write the equation. xy is equal to wx plus wy. This whole thing equals this guy plus this guy. Okay? xy is 17, wx is 6n minus 10, and wy is 3n. So I literally took those out and plugged the numbers in. Okay? Now we continue to solve. 17 equals 9n minus 10. Okay. Add 10 to the other side, we get 27 equals 9n. And divide, we get n to be 3. We're not done. I don't know. I think it's kind of, after you get an answer in mathematics, you just want to be like, oh, I'm done. And it's common to do that, but you always got to look back. Is there more? Of course there's more. Find the value of n and wx. How long or what's the length of wn? Ran out of adjectives, sorry. So wx, this guy. Well, I know this represents it, right? That's the length. I'm going to plug 3 into there. 6 times 3 minus 10. I think we want to get 8 for that guy. So I think A is my correct answer. 3 and then wx is 8. Okay. All right. Moving on. Okay, congruent segments. Congruent means that they have the same size, the same shape. And in line segments, if they have the same size and shape, they have to be the same measure, right? Okay? So since that's the case, then we can use a symbol for it. Okay? And this is the symbol. That little symbol, the equal sign with the little squiggly on top, that means congruent. And that means same size and shape. which we could conclude that it has the same measure. Let me give you an example. These two erasers, right? They're congruent. Same size, same shape. Okay? But let's talk about their measurements. Would their measurements be the same? Yes. So you see how I can kind of jump to that a little bit? Just be careful. Congruent doesn't automatically mean same measure. Okay? I know it kind of says it up there, but we should separate those just a little bit. Okay? So because they are the same, we could say that their measurements are the same. We could make that conclusion. Now, and this is good for proofs too. When you talk about geometric proofs, when you write it like this, you got to have the symbols. If you're talking about measurements, then you don't use the symbols. Equal and measure. So this is a measure approach. Okay, this is a size and shape approach. So there's a distinction there. I want to make sure you know that. Okay. Now, how do we show this? Well, we can show it by writing the measurement down. Both of these segments are 1.7 centimeters long. We can also use a tick mark, okay? If they have the same number of tick marks there, then they are congruent. So we can show it visually too, okay? So write a congruency statement for all of these guys. All right, so I have some space up here. Erase this. Well, I could see two of them real easily. There are 10 inches. What? AB can be congruent to EF. Do we agree with that? This guy and this guy are both 10 inches. They both have one tick mark, so we could say that they're congruent. A lot of ways of confirming it. Okay, another statement. We could say that MN is congruent to TV. They both have two tick marks, and they both are 5 inches. Lastly, would be what? RS is congruent to CD. They both are 3 inches. They both have 3 tick marks. Okay? So these are my congruency statements for that guy, for that problem. Why didn't I use just one tick mark for everything? Well, I think the answer is obvious, right? When you have a lot of segments combined together, you can't just use one tick mark for everything, because then you're going to get it confused, like which goes with which. Now, I emphasize the sizes here, so it's easier that way. But when the drawings are smaller, or let's say they're only off by like a 1/16 of an inch, that's where things get tricky. So using different number of tick marks for each one helps us separate what goes with what. Okay? So there we go. I could flip these, it's okay. There's a symmetric property of congruence that allows us to do that. If I flip this, it means the same thing. So I don't want you to feel like yours is incorrect if you flipped it. Or you could switch the letters, right? We know that that's okay as well. Okay? Last little example. We could look at a bar graph or just any type of graph the same way with congruence. This graph shows the percent of adults who participate in selected activities. Okay? So they got barbecuing, going to the beach, picnic, museums, zoo, board games, and electronic games. Okay? So they want to know which segments are congruent. So take a look at the graph. Which two are the same? And I think that's going to be what? Zoo and board games, they're both at 14%. They're congruent. Picnic and museums are both at 16%. That'd be the other set of congruent bars. Okay? So you can talk about congruency with different graphs too. All right? That's it. That is it, guys. That's line segments, okay? We learned how to measure them, how to name them with the symbol and without the symbol when we do it. We talked about the line segment addition postulate, what that looks like, how to set up the equation, and how to plug in numbers. We could add and subtract easily, and that's no problem, but it's just getting used to writing in mathematics, okay? And then we finish up with congruency and what that symbol means, okay? Size and shape. Use that if you're going to talk about the size and shape, and then use that if you're talking about their measurements, okay? Which, like I said, if They are the same size and shape. They are equal, but we got to make sure we use the right terms and symbols for it. All right, that's it. Not bad timing. Hopefully it's not a long video when I stop this. So have a good day. Hope you enjoyed, and I will see you all in the next video.